Look up at the sky. Every day we witness a blazing orb that bathes our planet in light and warmth, the sun. But do we truly understand the cosmic marvel that powers our existence? The sun is far more than just a shining ball of gas. It is the very heart of our solar system, a colossal nuclear furnace that has been tirelessly fueling life on Earth for over 4.6 billion years. Have you ever wondered how it came to be, or what fate awaits it in the distant future? Today, we embark on a thrilling exploration of our sun's untold story, from its explosive birth in a stellar nursery to its eventual demise as a red giant. Imagine a time when the sun was nothing but a cold cloud of dust and gas, waiting to ignite into the life-giving force we know today. Now picture a future where this same sun swells to engulf the inner planets, leaving Earth as a scorched memory. It sounds like something out of science fiction, right? But it's not. This is the real fate of our star. In today's video, we're diving into the epic timeline of our sun, revealing secrets about its past, present, and inevitable future that will blow your mind. Before we dive deeper into the mysteries of our sun, make sure to hit that like button and subscribe to Exploring the Universe. Join our growing community of space enthusiasts and stay tuned for more mind-blowing cosmic adventures. Trust me, you don't want to miss what comes next. Our journey through the cosmos is just beginning. Around 4.6 billion years ago, our solar system was nothing like the organized, harmonious space we see today. Instead, it was a chaotic region filled with vast clouds of gas, dust, and particles floating through the darkness of space. These regions, known as nebulas, are the stellar nurseries of the universe, cradles where stars are born. Our sun's journey began in one of these turbulent clouds. Over time, gravity started to work its magic, pulling the particles closer together. As the gas and dust condensed, a dense region formed at the center of this cloud, setting the stage for the birth of a star. This collapsing mass of gas, still invisible to us today, is known as a protostar. The temperature and pressure in its core began to rise dramatically as gravity pulled more material into the center. The denser it became, the more intense the gravitational force, causing temperatures to soar to millions of degrees. Eventually, this immense heat triggered a reaction at the heart of the protostar: nuclear fusion. This process involves hydrogen atoms smashing together to form helium, releasing massive amounts of energy in the form of heat and light. This is the very process that powers stars, including our sun. And it marked the moment when our protostar officially became a star. With nuclear fusion now raging in its core, our sun was born. A gigantic, glowing ball of plasma that would shine for billions of years to come. Stellar nucleosynthesis, the process where stars create energy through nuclear fusion, had transformed this once cold cloud of dust into the brilliant beacon we see every day in our sky. But this is just the beginning of the sun's story. From this moment, it began to shape everything around it, pulling the dust and gas in the surrounding nebula into orbit, forming the planets, moons, and everything that makes up our solar system today. As the sun settled into its role as the center of the solar system, it didn't just provide light, it became the driving force behind the creation of Earth and the conditions that would eventually allow life to flourish. Without the sun's energy, Earth would be a cold, lifeless rock, adrift in space. But with it, we have the warmth and light that has nurtured life for billions of years. The sun's birth was not just the beginning of a star, it was the beginning of life as we know it. For the past 4.6 billion years, our sun has been in a remarkably stable phase of its life, known as the main sequence. This is the longest and most stable period in a star's life cycle, and for us, it's the phase that makes life on Earth possible. During this time, the sun has been steadily converting hydrogen into helium in its core through the process of nuclear fusion. This fusion is what powers the sun, releasing an extraordinary amount of energy in the form of light and heat that radiates outwards, eventually reaching Earth. Every sunrise you witness is a direct result of this process, as the sun continues to burn through its massive hydrogen reserves. However, while the sun might seem like a calm, unchanging presence in our sky, it is far from still. In fact, the sun is a dynamic, constantly evolving ball of plasma. One of its most fascinating features is its rotation. Unlike a solid object, the sun doesn't rotate uniformly. The gases at the equator spin faster than those near the poles, creating complex magnetic fields. These magnetic fields can twist and tangle, occasionally snapping and releasing bursts of energy known as solar flares. These flares, along with coronal mass ejections, send waves of charged particles across the solar system, creating solar winds that interact with planetary atmospheres, including our own. These solar winds can cause beautiful auroras near Earth's poles, but can also disrupt satellite communications and power grids. The sun's magnetic activity also gives rise to sunspots, cooler regions on the sun's surface that appear as dark patches. These sunspots follow an 11-year cycle of increasing and decreasing activity, which directly affects the solar energy output. This cycle plays a critical role in space weather and can influence everything from climate patterns on Earth to the conditions of interplanetary travel. So while the sun's energy provides life and warmth, it also creates powerful cosmic phenomena that remind us just how dynamic and alive our star really is. Despite its apparent constancy, the sun's time as a main sequence star is not infinite. Currently, it's in a phase where it has a perfect balance between the outward pressure from nuclear fusion and the inward pull of gravity. But over time, the sun will slowly run out of hydrogen in its core. When that happens, the balance will be disrupted, marking the end of its main sequence phase and the beginning of its transformation into a red giant. For now, we can take comfort in knowing that the sun has enough hydrogen to sustain this stable phase for billions more years, but the clock is ticking in cosmic terms. The main sequence phase of a star like the sun is an extraordinary period of stability in an otherwise chaotic universe. It's during this time that planets, atmospheres, and even life can form, making our solar system a haven for the development of living organisms. However, as we explore deeper into the life of the sun, we'll discover that this stability won't last forever. The sun's future holds dramatic changes that will reshape our solar system in ways we can barely imagine today. As the sun continues its life as a main sequence star, a dramatic transformation awaits it in the distant future. In about 5 billion years, the sun will begin to run out of hydrogen fuel in its core, the essential ingredient for nuclear fusion. When this happens, the stable balance between the outward pressure from fusion and the inward pull of gravity will start to break down. Without enough hydrogen to sustain the fusion process, gravity will begin to dominate, causing the sun's core to collapse under its own weight. As the core contracts, it will heat up, and this increase in temperature will trigger a new phase of fusion in the surrounding layers. At this point, the outer layers of the sun will respond in a dramatic fashion. They will expand outward, transforming our familiar star into a red giant. This red giant will be vastly different from the sun we know today. Its outer atmosphere will swell to a colossal size, possibly stretching out to engulf the inner planets of the solar system, including Mercury and Venus. There is even a chance that Earth itself could be consumed by the sun's fiery embrace. Even if our planet survives the initial expansion, the intense heat from the swollen sun will render Earth uninhabitable, turning it into a scorched wasteland, with oceans boiling away and the surface becoming a barren, molten desert. As terrifying as this scenario might sound, it's important to remember that this event is billions of years away, far beyond the time frame of human existence. However, the red giant phase is a key chapter in the sun's evolution, and it gives us a glimpse into the inevitable fate of stars like ours. The transformation into a red giant is a natural part of stellar evolution, marking the transition from a main sequence star to the final stages of a star's life. The sun, once the life-giving force of our solar system, will become an unstable, aging giant. Its outer layers will continue to expand and eventually be lost to space, creating a beautiful planetary nebula, a glowing cloud of gas and dust that was once part of the sun itself. At the heart of this nebula, the sun's core will continue to contract until it becomes a white dwarf, an incredibly dense remnant of a star. Though it will no longer generate energy through fusion, the white dwarf will remain incredibly hot, glowing faintly for billions of years as it gradually cools. This tiny, dense object will be all that remains of the once mighty sun, a quiet reminder of its former brilliance. The transformation from a radiant main sequence star to a red giant and finally to a white dwarf is a testament to the incredible forces of stellar evolution that shape the cosmos. While the red giant phase may signal the end of life as we know it in our solar system, it is also a beginning in another sense. The material ejected by the sun during its red giant phase will enrich the surrounding space with elements like carbon and oxygen, essential building blocks for new stars and planets. In this way, the sun's death will contribute to the birth of new celestial bodies, continuing the cycle of stellar evolution that has been ongoing for billions of years. Though our sun's story will one day come to an end, its legacy will live on in the stars and planets that follow. As the sun completes its dramatic transformation into a red giant, a final and equally spectacular phase of its life will unfold. After billions of years of fusing hydrogen into helium, and later helium into heavier elements during its red giant phase, the sun will reach a point where it can no longer sustain fusion. Without enough fuel to continue, the sun's outer layers will be cast off into space, forming a brilliant and colorful shell of gas and dust known as a planetary nebula. This nebula will glow for thousands of years, illuminated by the intense radiation from the exposed core of the sun. At the heart of this planetary nebula lies the white dwarf, all that remains of the sun's once mighty core. A white dwarf is an extraordinary object. Though no longer capable of nuclear fusion, it is incredibly dense, packing the mass of the sun into a space roughly the size of Earth. The temperatures in a white dwarf can reach over 100,000 degrees Celsius, but without the ability to generate new energy, it will begin a slow process of cooling. Over the course of billions of years, the white dwarf will fade, losing its brilliance as it radiates away the last of its heat, eventually becoming a cold, dark remnant known as a black dwarf. But this final stage of the sun's life is far from insignificant. While the sun itself will no longer shine, its impact on the universe will continue. The planetary nebula it leaves behind is not just a beautiful spectacle, it is a nursery for new stars and planets. The ejected material contains elements such as carbon, nitrogen, and oxygen, vital ingredients for the formation of new celestial bodies. These elements, forged in the intense heat of the sun's core, will drift into the interstellar medium, where they can be incorporated into new stars, planets, and potentially even new life forms. In this way, the sun's death is not an end, but a contribution to the ongoing cycle of creation in the universe. The transformation into a white dwarf marks the end of the sun's active life as a star, but its influence will persist for eternity. The gravitational pull of the white dwarf will still hold sway over the solar system, though the planets that survive the red giant phase will find themselves in a much colder, darker environment. Over time, the remaining planets will either be flung into space due to gravitational interactions or slowly spiral inwards towards the white dwarf. While this future may seem bleak, it is a natural part of the life cycle of stars like the sun. In the grand tapestry of the cosmos, the sun's journey from a bright, life-giving star to a faint, cooling white dwarf is a story of both endings and beginnings. It reminds us of the incredible forces that govern the universe and the delicate balance that allows life to flourish in the brief window of time when a star like the sun is stable. Even as the sun fades into obscurity, its legacy will live on in the stars, planets, and potentially life forms that emerge from the matter it leaves behind. The story of our sun may one day come to a close, but its impact on the universe will be felt for eons, contributing to the endless cycle of cosmic evolution. From the moment life began on Earth, the sun has been our constant companion, guiding the rhythm of days and seasons and providing the energy that sustains every living thing on our planet. But as we've seen today, the sun's story is far more complex and awe-inspiring than many of us realize. Its life cycle, stretching over billions of years, shapes not only the solar system, but also the future of humanity itself. By understanding the stages of our sun's life, from its fiery birth to its inevitable death, we can better appreciate the fragile balance that allows life to exist. This knowledge reminds us that, just like the sun, all things have a beginning and an end, and that life itself is a fleeting yet beautiful moment in the vast timeline of the universe. If you found this cosmic journey through the life of our sun as fascinating as we have, don't let the adventure stop here. Make sure to hit that like button. It's a small action, but it helps our community grow and reach more space enthusiasts like you. And if you're eager to explore more mysteries of the universe, don't forget to subscribe to our channel, Exploring the Universe, so you'll never miss an update on our next deep dive into the cosmos. We have plenty of exciting topics lined up, from black holes to exoplanets, and your support ensures we can continue bringing you the latest in cosmic exploration. But we want to hear from you. The sun's future as a red giant may seem distant, but it raises profound questions about the fate of humanity. As we prepare to face the cosmic changes that will one day come, do you think humanity will find a way to survive beyond Earth? Could we colonize other planets? or even venture beyond our solar system to find a new home among the stars? Share your thoughts and predictions in the comments below. Your ideas could spark the next big conversation about humanity's future in space. After all, every great discovery begins with a simple question, and your insights might just inspire the next generation of explorers. So join the discussion, engage with the community, and keep your eyes on the stars. The story of the sun isn't over yet, and neither is ours. Together, let's continue this journey of discovery and wonder, and who knows, maybe one day we'll find ourselves traveling to distant worlds, carrying the legacy of our sun with us as we explore new frontiers in the universe.